Good evening, ladies and gentlemen. It's good to see you this evening, and I thank you for those of you who were here yesterday for being back tonight to begin a new series of studies. And if you're a guest with us tonight for the first time, welcome. You have come tonight to hear a science lesson, whether you realized it or not. We're talking about a general theme this series, Christianity and science, conflict or coherence. I take the title for that lesson from this book by Henry F. Schaeffer. The elders of this church have said I can take this lesson and treat it like a science classroom. So you are my class. Welcome. Glad to have you. That means you can interact with me in the class, and I expect lots of good interaction tonight. So I expect rapt attention and lots of participation. So my first question to you is, how many in this room have ever heard of Henry F. Schaeffer? One person. Most people don't have a clue who this man is. But I will tell you, he's a highly respected physical chemist, widely known around the world. And he has won the equivalent of a Nobel Prize in chemistry. He's a phenomenal person. This book is based on lectures that he gives on college campuses, Why Christianity and Science Agree. He's a deep believer in God and a world-renowned scientist. And in this book, he references numerous scientists, both in previous generations and at the current time, who are believers in God and well-respected scientists. So can science and Christianity agree? By the way, he also is a firm believer that Jesus Christ is the Son of God. I love that. And if you want to look in detail about folks who believe that and are also very well-renowned scientists, read this little book. I highly recommend it to you. So that's going to be our theme the next 3 days. And here's what I do when I do this series in a church building. This church has decided they want the series to be here. I love it when we do it in a college science classroom. And typically in that setting, I don't quote from the Bible at all. If you're in my class and I pause, that means I said something important just then. And the reason for that is this. This Bible, which I believe is the Word of God, and my guess is most of you in this audience tonight believe the same thing. This Bible says you can come to believe in God without this Bible. So I want to introduce my lesson tonight, since we're in a church building, by hearing from this book first. But I'm telling you, class, we don't have to have this book to come to be believers in God. So let's turn to a couple of passages of Scripture, since we're in a church building and you probably brought your Bible with you. Let's turn to the Old Testament first, to the book of Psalms, chapter 19, and read just a few verses. Psalm 19 says, "The heavens declare the glory of God, and the firmament shows his handiwork. Day unto day it utters speech, and night unto night reveals knowledge. There's no speech nor language where their voice is not heard. Their line has gone out through all the earth, and their words to the end of the world." The psalmist in the Old Testament declares that the natural world declares God. And this is not the only passage in the Old Testament that teaches that. So, the book that is the basis for Christianity teaches that the natural world testifies of God. The New Testament passage I want to emphasize and is in Romans chapter 1. So let's turn to that one if you would. I would say to you, this is our theme passage for this 3 days, if you want to start with this book. Romans 1 verse 20 says, "For since the creation of the world, His invisible attributes," that is, God's invisible attributes, "are clearly seen, being understood by the things that are made, even His eternal power and Godhead, so that they are without excuse." What does that passage teach? It teaches that you can see the invisible God by the things that are made. And what can you see about Him? He's eternally powerful, and He is not part of nature. He's divine. And that is, based on the observation of nature, you can come to believe in God. That, ladies and gentlemen, is what we call the argument from design. You see the evidence of design everywhere in the natural world, and it leads you to believe somebody designed this. That's the argument. Now I want you to listen to verse 21. "Because although they knew God, they did not glorify Him as God, nor were thankful, but became futile in their thoughts, and their foolish hearts were darkened." Folks can come to know that there's a God based on the evidence of the natural world. So, class, I'm through with my introduction tonight. And for the rest of my time this evening, we're going to be turning to God's other book. I hope our man's okay, is he? You may need to help him out because I think he's having trouble. Are you okay? Okay, good. I've learned long since when something like that happens, you just don't keep talking because it doesn't help anyway. I'm glad you're better. All right. So I'm back to my introduction, which I just finished. And what I'm telling you is this book teaches that what we're going to do for the rest of our time this evening is a perfectly legitimate way to lead you to believe in God. Now, most of you in this room already believe in God. So you say, why are you doing this? I'm doing it because lots of folks do not believe in God. And we need to relay that foundation in every generation. And the young people of this generation are being bombarded by atheists who are evangelistic. I've lived 80 years almost. I've lived 80 years. And I've never seen atheists be evangelistic like they are right now. Why would you want to be evangelistic about being an atheist? That's a hard thing for me to grasp. But they are. And they're trying to convince our young people that belief in God is foolishness. What I want to convince you of in these 3 lessons is that there has never been a time in the history of mankind where there was more evidence for the existence of God in the natural world. And for the rest of my time tonight, I'm not using this book. Please don't take offense at that if you're a believer in this book, because this book says what I'm about to do is perfectly legitimate. We're going to look at God's other book, the book of the natural world. So, class, are you ready for a science lesson? The answer is yes. Thank you. That wasn't very enthusiastic. Yes. So may I ask it again? Are you ready for a science lesson? Yes. That's much better, and I expect you to be that level of enthusiasm all the way through. Yes, sir. Thank you. Many of the key scientists in the Age of Enlightenment, that was the Renaissance, AD 1600 to 1800, were strong believers in God, in Jesus as the Christ, and in the Bible. That is a fact, ladies and gentlemen. The folks who absolutely founded the basis of modern science were mostly believers in God. Here's one, Johannes Kepler, 1571 to 1630. How many of you have ever heard of Johannes Kepler? Okay, good. I'm glad to see you're that knowledgeable of a person that old. He was a great astronomer, and he is an amazing human being for what he accomplished at his time. Because, folks, he did not have access to a lot of the things we have today. For example, you algebra students remember logarithms? And you remember how pleasant that was to figure out how to use logarithms? That was a tedious way of doing mathematics. But it did allow you to do extremely complicated multiplication and division problems by adding and subtracting. But it took a lot of work. This man did that kind of tedious work with regard to the solar system and figured out what came to be called the planetary laws, based on careful observation and a lot of heavy mathematics. Amazing. But I want you to listen to what he said about himself and others. I was merely thinking God's thoughts after him. Since we astronomers are the priests of the highest God in regard to the book of nature, it benefits us to be thoughtful not of the glory of our minds, but rather above all else of the glory of God. Don't you love that? Nowadays, scientists who are unbelievers praise themselves about what all they've learned. And all we're doing, folks, is thinking God's thoughts after him. And this man openly confessed that. All right, how about this one? How many have heard of this Isaac Newton? Well, everybody should. He's only the most famous scientist that ever lived. I would call him the greatest, partly because he independently invented the calculus, which I taught for 35 years, and is only the most important subject you'll ever take in mathematics, because it's foundational to everything else you do, and it's a study of infinity, class, and you'll never get closer to thinking God's thoughts after him than dealing with infinity. And there's a lot we've learned to do with infinity. Hard to believe, isn't it? But the calculus answers all kinds of solutions to problems that involve infinity. And he invented it. Not only learned how to do it, but invented the very notion. He also formulated the classical laws of motion, and he invented and applied the universal law of gravitation, the first one to express it mathematically. I'll give it to you briefly. The force of gravity is equal to the G, that's the gravitational constant, times the mass of one object times the mass of the other divided by the distance between them squared. I know you remember that and love it. That's the inverse square law of gravity. You see, gravity depends on how close two objects are to each other and the masses of the two objects. And he learned that by observation, and he expressed it mathematically. You never get closer to thinking God's thoughts after him than by expressing them mathematically. And here's the fascinating thing, class. We use that law of gravity today to predict what's going to happen when you send a spaceship to Pluto. Did Newton even have any concept we'd ever send a spaceship to Pluto? No, but we're using his mathematical law to predict what happens. Did you know that on that trip to Pluto, which has already happened, by the way, was a 9.5-year trip? You heard what I just said, right? And the whole itinerary for that trip was mapped out ahead of time and written down. This is what's going to happen. And one of the pieces of that was it was going to pass by the planet Jupiter, go around that planet, and use the gravitational force of that planet to shoot it off into space and save 3 years on that journey. It started with this man, 1687. That gives me chill bumps. Say it again. Yeah, well, it was called the space mission to Pluto. That Voyager went ahead of it, and it's still out there, and so is this one. He also built the first practical reflecting telescope. He pioneered studies of light and optics. Class, we could spend the next 6 weeks talking about how he discovered things about light. Light's an amazing thing, and it affects everything we do. And then he theoretically determined the speed of sound, and I could fill this board with lots of other things that he uniquely accomplished. Greatest scientist of all time, and here's one of his famous quotes from the General Scholium of the Principia, his most important work. Though these bodies, speaking of the solar system, may indeed continue in their orbits by the mere laws of gravity, yet they could by no means have at first derived the regular position of the orbits themselves from these laws. Thus, this most beautiful system of sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being, capital B. And might I say to you, class, Isaac Newton wrote more information in written form about the Bible than he did about science. That is the truth. So, it was a common thing in those days to take a class like this, natural theology, or evidences of the existence and attributes of the deity collected from the appearances of nature. This one happens to be by William Paley, published in the early 1800s. And young people in this class, and some of you older folks too, if you were in college right now in the 1800s in England or in Europe, you'd take that class. Everybody took that class. And it started with this, the famous watchmaker argument. You've probably heard that, haven't you? Since William Paley was British, may I introduce that argument by using a bit of British. So he would say, welcome class to natural theology. I begin the class with this experience. Suppose we were walking in the heath and we kicked over a stone. And someone asked, how did that stone get to be there? It may very well be that your response would be, it's been there forever. And I doubt anyone would question you. But if you walked on the same heath and kicked over the stone and there lay a watch, you picked up the watch and examined it carefully and you said to somebody, or somebody said to you, where did that come from? How did that get there? Highly doubtful you would give him the same answer. Rather, you would say, certainly there must have been some artificer who put this together, who constructed it with all its circles and combinations and springs. Must have been a designer. And might I tell you, class, when one observes nature with all of its properties, we find much more things complicated than a watch. Everywhere you search in nature, you find things with much more design than a watch. Welcome to the class where we'll study those evidences. So welcome, class, to natural theology. Okay, sir, Eric, what are we doing? While I pause here, may I say we have a great AV guy? But you can't do this lesson without the AV. So did I turn the thing off? I'm innocent.
Everything's on the right side here.
Yeah, the projector just turned off. You know why I have an AV guy, folks? Because I have a talent. I can break almost anything. I do this kind of lecture in lots of places. I don't think there's been a time that I've done this that something hasn't gone wrong. And it's usually my fault. So I need somebody to recover. Are we back?
Yes, sir. For now.
Thank you. So you were properly introduced to William Paley's class on natural theology, a class, by the way, taken by Charles Darwin. And Charles Darwin was so impressed with this class that he decided to be a preacher. You aware of this? and was in college to study to be a theologian. He was also quite interested in the natural world. And he eventually was appointed to go on a ship to sail around the world and be the naturalist. It changed his whole life and the whole direction of his life. And he began to believe, as a result of his observations on that journey and many others, that things had been taught him that he didn't believe anymore. And so things for him began to change. So what I want to talk to you about for the next few minutes is, how did we get here from where we were in the early 1800s? How is it that in our generation, in 1980, in the Cosmos series, Carl Sagan, by the way, who was one of the professors when I was at Harvard — I never had Carl Sagan, but he was a widely respected physicist and astronomer, and this is the most popular science series that's ever been on television. And it started with this statement: the cosmos is all that is, or was, or ever will be. And may I say to you, ladies and gentlemen, that is not a scientific statement. That's a statement of philosophy. Carl Sagan believed it with all his heart, that there is nothing but nature. That's all there is. The cosmos is it. And everything you observe can be explained by the cosmos itself. That's his position. And that has come to be the dominant worldview among a large percentage of scientists in our time. It's the exact opposite of what scientists believed in the early days of science. How did we get there? And here, this makes it even worse. I quote now from Richard Dawkins, British evolutionary biologist and author, professor of the public understanding of the sciences at Oxford University in England. That's a prestigious university, ladies and gentlemen, that appointed this man to be the scientist that explains to all of us common folk how science works. That's why I quote him a lot, because he pretends to be the spokesman for science. Well, no, he doesn't pretend it. He was appointed by that school to be that. And he's one of what we call the four horsemen of modern day evolutionary science. So here's what Richard Dawkins has to say in his book, The Selfish Gene, 1976. Faith is blind trust. I'm going to interrupt that just a moment. That is the thing I have seen the most in my lectures on science classrooms, in science classroom with lots of evolutionists in the audience. They cannot stand the notion that there's some faith involved in what they believe, because they believe it. That's what faith is all about. But they don't want to say that. No, he likes to think that faith belongs only to religious folks who believe in God. And he calls it blind trust. It's like we just accept things. We don't even think about it. It is the absence of evidence. Even in the teeth of evidence, it's a process of non-thinking. By the way, did I tell you he's not very nice? He says very ugly things. And may I interrupt my quote here just a moment and say to all of us who are in this audience, who are believers in God, if you're trying to respond to somebody, you don't have to be mean and ugly about it. In fact, it really is not the way to do things. So don't be accused as a believer in God of someone who improperly represents someone else, who doesn't tell the truth about it, or he calls them ugly names. It's not helpful. Richard Dawkins is terrible about that. And he's supposed to be to tell the public what science is about. Science shouldn't function that way either. But it gets worse. In his book, The God Delusion, in 2006, he said, if this book works as I intend, religious readers who open it will be atheists when they put it down. I told you they're evangelistic. He's out to convince your children and you there is no God. And he believes absolutely and with all his heart. I give him this. I'm convinced he firmly believes what he's saying. But folks, he believes it. He has not proved it. And it goes on. God is a delusion, a psychotic delinquent invented by mad, deluded people. Well, that's not very nice. Thank you. He's talking about me there, class. And you too, you foolish God believers. And God himself is a psychotic delinquent. One of these days, this man will give answer to God for that. And that is no way to be talking in polite discourse. So how did things change so radically in 200 years? I'm going to run through the fastest history of science treatment you've ever had. I may speak at 150 miles an hour, but we don't have time for a whole lot of this, but I want you to see how this evolved since the 1800s. Pierre-Simon de Laplace, 1749 to 1827, thought he was the next Isaac Newton, and he was far from it. But he said this: nature, with its matter, energy, and forces, could produce and maintain our solar system. There is no need for a God hypothesis, said this presumptuous human being. No need for a God hypothesis. Nature itself can explain it. The cosmos is all you need. That was the beginning, among others, of those who started drifting away and leading away from the notion that most of the early scientists had in their minds. Charles Lyell, in his book Principles of Geology, an attempt to explain the former changes in the Earth's surface by reference to causes now in operation. This book greatly influenced Charles Darwin. He studied it carefully. It opened the door for him to think we have millions and billions of years to deal with, and you don't need anything to explain all the past formations in geology except geology itself acting upon matter. So you don't need God there either. And then Charles Darwin came along with his text, published first in 1859, on the origin of species by means of natural selection. Have you ever read the subscript to his book? I hope you can read it from back there. It says, or the preservation of favored races in the struggle for life. Did you know that was the subheading of his book? Is it any wonder, class, that later in the 1900s, when Hitler took over in Germany, he loved this book? Because it gave scientific credence to his destruction of entire races of people. How could you do that? Because nature itself teaches you that what survives is those who win the struggle for existence. And the favored races are the ones that survive. So who's the favored race? Mine. And so if I choose to destroy your race, that's perfectly in accord with what nature teaches. Now, a lot of folks don't like that result, but I challenge you to explain to me why you could not go there if you believe this. Darwin says there's no need for a designer to account for the origin of species of life. Natural selection, acting upon natural variation, accounts for the appearance of design. He admits there's an appearance of design everywhere you look. But he said you don't need God for that. Nature itself can do it. Natural selection, acting on natural variation, explains it. And I'll tell you what Richard Dawkins would tell you if he were here tonight. He'd say, class, Darwin's theory gave me the first opportunity in my life to become an intellectually successful atheist and satisfied. He believes natural selection can explain all the living things you see acting on the physical forces of nature. And so Darwin taught. And in the late 1800s and early 1900s, O'Perrin and Haldane came up with the theory that there's no need for God to produce life from non-living matter either. Their theory was, in the early earth, the situations were different, circumstances were different, and under those circumstances, non-life could produce living things. So you don't need God there either. So little by little, step by step, we removed God from every sphere of understanding where we came from. To the point that in our day, Dawkins and his ilk will say to you, you don't need God and you better get over it. May I pause here a moment and tell you, at Harvard University in the 1960s, when I was in the school there, professors would say to the students in their classes, if you're a God believer, you best get over it soon, because before very long, we're going to understand how all of these things happen by natural causes. God is not needed, and all you're doing is sticking God in where the gaps of your knowledge exist, and the smaller those gaps get, the less the need for God. And may I say to you, as a college and high school student, as I was facing such things, I had no idea how to handle that. But it was very challenging. And it was challenging to my faith in God. That's why, class, I'm still doing this 60 years later. Because it's important. And I hope I will convince everybody in my hearing there is a massive amount of reason to believe in God. We don't believe in the God of the gaps. The more we learn about how things function, the more evidence there is for God, not less. And that's my goal, to try to convince you. But I can tell you, in the 60s and 70s, the animus there was very strong, and it was based largely on these scientists who spoke to us so firmly and convictedly. I say it's time to revisit the argument from design, class, and that's what we're going to do. So we start with this. Stephen Meyer has written 3 books. The Signature in the Cell, which is a study of DNA. Highly recommend it. It's about that thick. So you may hesitate a little bit, but you can skip parts of it. It's an amazing book to have relatively updated information about what we've learned about the cell and the DNA in it. Darwin's Doubt is a book about the origin of the first life. And that was one of Darwin's biggest doubts. He didn't know how that happened. He had no clue. And by the way, here 60 to 70 years later, from the 60s when I was in school, we know less today about how life started from non-life than we thought we did then. It's way more complicated than we ever dreamed. But I love this particular book, his latest one, The Return of the God Hypothesis. Now, if you were listening to me, you know where that title came from. Because Pierre Simon de Laplace said, we have no need of the God hypothesis. And in this book, Meyer argues there's a return of the God hypothesis, and he explains why. And that will form the basis of much of what I'm going to say these next 3 days. And here's what he said. There are 3 scientific discoveries that have happened in the last 70 some odd years. Evidence that has become overwhelmingly strong that, number 1, the universe, space, matter, and time had a beginning. Did you know that most atheists through the ages have said matter's eternal? You don't have to explain where it came from because it's always been here. And matter itself produced everything you see. Now, class, the evidence of science is overwhelming that matter, space, and time had a beginning. That's a big old problem for Richard Dawkins. and his kind. Because then, if you had a beginning to all of those things, they can't be the reason that they came into existence, can they? No, something else has to come in. And it makes them back up and have to explain this. And by the way, they've tried to explain it. There's a new book out by Krauss, a physicist, that says the universe came from nothing. Isn't that good? And spends a whole book explaining how the universe, everything you observe, came from nothing. Only it wasn't really nothing. The fact is, class, science today supports the idea there was a beginning. I have chosen in this series not to deal at length with that subject, but I'm going to give you a bibliography. Did you get that today? I emailed it to you. He's going to have a bibliography that's got a whole bunch of books referenced in it. If you want to go study that topic more deeply, please do. And by the way, while I'm on that topic, I don't want you accepting anything I say because I said it. I will tell you where I got it. You can go look for yourself and examine the evidence for yourself. You got it. And by the way, it has stars by the best books. So we're not going to talk about that particular one, but I'm telling you it's the truth. The evidence from science is there was a beginning. Second, the universe, our solar system and Earth are remarkably fine-tuned to support life on Earth and have been since the beginning. Everywhere you look, class, things are fine-tuned to support life here. Fine-tuned. And that's one I'm going to explain to you in some detail. And third, even the simplest forms of life at the biochemical level contain massive amounts of digital information being used to produce and maintain an untold number of molecular machines and complex processes. That is a fact, class, and we've learned more about that in the last 75 years than in all the history of mankind before this. And that's chemistry right there. And you're looking at a chemistry teacher here, folks. That's my favorite topic. So we're going to spend time on these two over the next 2 days. I'm so excited about that. So here we go. We're looking at the fine-tuning argument, class. So I thought I'd start with a book by a total atheist. His name is Paul Davies. And his book is called The Goldilocks Enigma. What's an enigma, class? A what? A mystery, a puzzle, something that's hard to figure out. Wonder why he calls it Goldilocks. Y'all know the story of Goldilocks, don't you?
Just right.
Yeah. Goldilocks went out into the woods. She went to the house of the what, kids? The 3 bears. Went inside. On the table were 3 bowls of porridge. Y'all help me with this. So she sat down at the table and took a bite of the first bowl, and it was too hot. So she went around, took a bite of another bowl, and it was too cold. And then she took a bite of the third bowl, and it was just right. That's why he calls this the Goldilocks Enigma. Because everywhere you look, things have to be just right, or you wouldn't be here. And I mean, everywhere you look, that's what we're learning. So let's talk about a few of those. Here's a quote from him. One of the most significant facts, arguably the most significant fact about the universe, is that we are part of it. Would you agree with that, class? How did we get here? That's an amazingly difficult question. And I will tell you, the only way that could possibly have happened is everything was just right. Everyone agrees that the universe looks as if it was designed for life. That's an atheist talking. It looks like it was designed for life. Oh, yes, it does. Everywhere you look. And here's another quote from him. The really amazing thing is not that life on earth is balanced on a knife edge, but that the entire universe is balanced on a knife edge. And would be total chaos if any of the natural constants were off even slightly. So let me introduce it this way. Look up here. Here's a machine. It's a universe-building machine. It is covered with dials. And each of those dials has to be set to a certain place in order for this machine to construct a universe like we observe. You with me so far? I'm making this up, you understand? But I'm trying to picture what the thing is. And here is the reality. Of those hundreds of dials, you take one of them and turn it just 1/9th bit, and you wouldn't be here. Period. The law of gravity, remember I told you that one? It has a constant called the gravitational constant in it. If you change that constant 1/10⁻², I just lost you. 10⁻³ is 10 with 34 zeros. 1 divided by that, would you call that a T9C number? If you change the gravitational constant by that little bit, you wouldn't be here. Because there'd be no universe. Now, you don't have to believe me about this, but the interesting thing about what I'm going to talk to you about for the next few minutes is everybody agrees with these facts. This is like a law case where both the defense and the prosecution have the same evidence, and people agree on the evidence. What they disagree on is what it means. I'm telling you, class, out of all those dials, every one of them's the same way. If you change this one little T9C bit, you wouldn't be here. How about this one down here? Same thing, everywhere you look. In the 1960s, when I was in school, we had discovered 12 characteristics of the cosmos and our solar system that were fine-tuned to make human life possible. 12. So you're my jury. If we had 12 things, all of which had to be exactly right, could you believe that could have happened by itself? Maybe. 12 coincidences? Maybe. Let me tell you where we are now. By 2020, at least 50 books have been written about the anthropic principle, and they've been published documenting it. And from these books, Hugh Ross and his crew says there are over 800 fine-tuned characteristics as essential for any potential human life site in the observable universe. They say there's over 800 different things on that dial that all have to be just right, or you wouldn't be here. Now, class, if you were on a jury and I told you there were 800 different things that just happened to be the way they are, would you buy that? If you would, I have a bridge to sell you in the Everglades, which doesn't exist, by the way. No, class, what we've learned is there's a whole bunch of things that have to be just right. So I'm going to introduce to you the book. I think if you're a parent or you're somebody who hasn't really studied this much, you start with this book. It's called God's Crime Scene. It's by J. Warner Wallace. J. Warner Wallace grew up in a family of atheists. His daddy was a detective in the police force, and he's still an atheist to this day.
I've got that book. I'll run it to anybody.
You'd recommend it, huh? It is good. It's good. J. Warner Wallace has become a believer. He also is a detective. He's a cold case detective. And you know what that is? That's a guy that takes a case that nobody else has been able to solve, and then he solves it. And so what he does in this book is he takes the things he uses as a detective to examine the universe. So he makes the universe the crime scene. And every chapter is a chapter about one of his cases that he solved. So I'm going to share with you one piece of the chapter 2. I'm going to read you just a little bit. This is nighttime reading, and you're not allowed to go to sleep. The title of this chapter is Tampering with the Evidence. Tampering with the Evidence. Helen knew something was wrong when her daughter Carrie failed to answer the door. It was a bright summer afternoon. Carrie said she'd be home, and her car was indeed parked in the driveway. Helen tried to peek in through the living room window, but the curtains were unusually drawn. Carrie never locked the back door, but when Helen walked into the backyard of the old house, she found the back door locked and all the windows closed. The windows were not closed normally. This wasn't like Carrie at all. Helen began to panic. She knew that Todd and Carrie had a tumultuous marriage, one that included physical violence. Todd had moved out, but Helen still feared for her daughter's safety. You see, the couple had a child named Lexi, but the violence had only intensified since Lexi was born. A week ago, Todd had threatened to kill Carrie. And just last night, Carrie confided to her mama there had been yet another fight. When Helen could not get Carrie to answer the door that afternoon, she decided to call the police. I don't have time to read you all this, class. The police came and they started their investigation. They found some very interesting facts over time. There was a pocket door at the bottom of the stairwell. By the way, when they first went in, there was such a strong gas smell they had to get out and bring in the hazmat team. Once they got inside the house, at the door, bottom of the stairwell, was a pocket door that was never closed. It was closed. The old door had come off its rail. Second, the door to the master bedroom upstairs was closed and a pile of laundry piled in front of the door. Carrie would never allow dirty laundry left on the floor. When they got into the house, they found the source of the gas. It was a retrofitted gas heater that was mounted to the wall separating the bedroom from the upstairs hallway. The pilot light was out, but the gas valve was open full blast. And the straw that broke the camel's back, ladies and gentlemen, is they learned that 2 days prior to the death, because they found 2 dead bodies in the bedroom, guess who? Carrie and Lexi. Todd had paid to restart the gas service, which had been off. They opened a crime case because the evidence inside the house could not account for their deaths. Somebody tampered with this. You with me? Then he goes on to say this. We were compelled to examine the evidence of tampering because one important fact, there were 2 dead bodies in the house. In a similar way, when we look at the nature of our universe, the existence of the living bodies ought to provoke an investigation. And just like our murder scene, there are foundational, regional, and locational conditions that demand explanation. The foundational laws of physics in our universe, the regional properties of our solar system, and the locational conditions of our planet itself all have allowed for life to exist on this planet. If things were slightly different, we wouldn't be here. If things had been slightly different in this house, there wouldn't be 2 dead bodies there. So how'd that happen? May I tell you the end from the beginning? Todd was convicted of first-degree murder of his wife and daughter, and nobody observed it. It was all circumstantial. But the evidence was so powerful, the jury unanimously convicted him of 2 first-degree murders. His point is, circumstantial evidence is what we're going to deal with when we look at the crime scene of the natural world. But you can be overwhelmed with that evidence and be convinced somebody designed this. And then he proceeds to go on. Isn't that good? And he uses facts about the natural world. So let's go on. What are some of those? The laws of nature. Every one of them's fine-tuned, class. The ratio of the weight of an electron to a proton has to be precise. The gravitational constant has to be precise. And 100 others. We don't have time to talk about all that. But what about regional? We have to be in a right kind of galaxy, you know. You think just any galaxy will do? The answer is no, and everybody knows it. So I thought I'd introduce this to you. You've probably heard of the James Webb Telescope, put up in the space in 2022. Now, all of you were alive then, so you remember this. And what I'm about to show you is the first picture, collective picture, that this telescope has given us, that was presented to us by the President of the United States in 2022. And I'm doing it for a reason. When you look at the announcement NASA made about this picture I'm about to show you, everybody's eyes on me. They said, if you took one grain of sand between your fingers and held it at arm's length in front of your eye, the amount of space blocked out by that little grain of sand is what you're getting a picture of. Did I make that clear? Let me try again. Take a grain of sand and hold it up here and look at it. The amount of the universe blocked out by that little piece of sand is what this picture is that I'm about to show you. And it's stuff we'd never seen before because we couldn't see that far away. Okay? Are you with me? Do something with your head. I mean, you're kind of just sitting there. You got it, right? Okay. Next thing we're going to do is turn off all the lights. Don't go anywhere. I want you to see this without all the light pollution. Get that light off back there. I know he's in there with a baby. I don't care. I want the lights off. What is this? I told the deacons these lights were to be off. 100% of them. You can't turn off exit lights. Okay, that's all right. Thank you. All right, your eyes up on here? They named this the Galaxy Cluster SMACS 0723. First published July the 12th, 2022. Never been seen before, class. Let me point out some things. You see these globs here? You say, look at all those stars. No, class, those globs are not stars. They are galaxies. And each one of those galaxies probably has 300 billion stars in it. You see that one right there? That's called a spiral galaxy. Can you see the spirals? Yeah. Can you find another one of those? Here's a smaller one. I'm not seeing a lot of spirals. You see a lot of globular ones. See these globular ones? Most of those are galaxies, class. Would you say there's lots of stars out there? I'm telling you. We haven't touched the hem of the garment yet because we haven't had the capacity to see out there yet. But they're there. All right, let's get the lights back on. Thank you guys for doing that for me. Here's what we've learned, class. To have a solar system like ours with planets and life on one of those planets, to function the way it does, you can't just be in any old galaxy. A whole lot of galaxies are elliptical like this. If your galaxy were like this, there would be no planetary system like we have. Everybody knows that. Because the forces acting inside there are too phenomenally difficult to support such a thing. How about an irregular galaxy? That's not going to work at all either. There's 16 reasons why not. Get the books. No, it has to be a spiral galaxy. What kind of galaxy do you think our sun and its solar system live in? A spiral galaxy. Isn't that an interesting coincidence? That the very kind of galaxy you have to support a solar system with life around it, like ours, happens to be in the right kind of galaxy. Now, folks, if you're on a jury and I'm trying to convince you somebody designed this, that's where I'd start. Look, here's one coincidence. Plus the other 100 I've already pointed out about the foundational properties of nature. And we're not anywhere near finished. Because if you look at that spiral galaxy sideways, like that, it has this big glob in the middle. You think if the solar system were sitting right there, it would have life around it or would even exist? Folks, if it were in there, there's so many forces acting on it, it wouldn't be there. There wouldn't be any planetary system. You can't just be anywhere in this thing. I'll tell you where you need to be, right here or right here. And like 149 out of 150 pieces of the volume is eliminated. Right? Your solar system needs to be either there or there. Guess where our sun is? Right there. Isn't that interesting? That's another coincidence, class. And there's very little variability there. It has to be, say it. That was terrible. It has to be just right. Exactly right. It has to be just right. But that's not all. It has to be the right kind of star. You haven't the slightest appreciation for our star. I want to get you a little more appreciative. Here's our star. It's kind of a mock-up. This is our sun. And here's Jupiter and all the other planets. There's Earth. You see it down here? And Pluto right there. By the way, it's still a planet. I don't want to hear it. And you think, man, the sun's a massive object. Well, not if you compare it to some others. Here's our sun compared to Sirius, the dog star, and Pollux and Arcturus. But it gets worse. Here's Aldebaran and Betelgeuse and Antares. And where's the sun? It's right there. Can you see it? No, and neither can I, so don't say yes. You can't see it. It's 1 pixel big compared to Antares. What that says, class, is our sun is a relatively small star compared to the biggest stars there are. But did you know there's a whole bunch of stars smaller than our sun? They're called dwarf stars. And our sun happens to be right smack dab in the middle. That makes it. Are you there? That makes our sun just right. And it is. But it's not just the size of the sun, class. That sun that is ours gives off the exact right kind of energy that we need on Earth to support life. And it would take me 6 days to explain that in detail to you. But it's not just the size of the star. It's the temperature of the star. It's the radiation that it puts off. All of those factors come into play when you say this sun, for supporting life in a planetary system, is just right. Do I have time to talk about all that? No, but I'm trying to get the point across. How many coincidences can you put up with before you say, somebody tampered with that? The location of the planet's important. You can't just have any old planet. So here we go. These are our planets in our solar system. Do you think there's life on Jupiter, class? If you do, you need your head examined. There's no way. These planets are way too large. They have all kinds of problems. So how about Earth? Well, we're covered up with it. How about this one, the next largest planet? Do you know what that one is? No, it is not Mars. It's Venus. Is anybody looking for life on Venus? Is NASA planning a trip to Venus to look for life? No, it is not. You know why? Because it's a stupid planet. I'm sorry. It rotates backwards. The temperature gets up around 900 degrees, and most of its atmosphere is sulfuric acid. You think that's a good place for life? No. Nobody's looking for life on Venus. There are more factors to consider than just the size of the planet, class, and even its location. It has to be in the moderate zone around the particular star, and that's exactly where we find our Earth and Venus, and what's the other one we are looking at? Mars, which is this one right here. And what are we looking for on Mars, class? Some form of life, but what are they really looking for? Water. Why is that? You can't have life, class, without water. And carbon-based products. There is no such thing as life without those things. And have we even talked about that yet? No, that's way down the line. We're not finished. But why are they looking for water on Mars? Because they know good and well if there wasn't water there sometime or another in the past however long, there wasn't any life. You can't have it. Where have we got water here? We're 70% covered up with water, class. Much more could be said about that. But you see, it's not, there's a whole bunch of locational fine-tuned factors right here on Earth. How about the proper mass, spin, tilt, the moon, the atmosphere, and its crust? All of those could take a month. How about this one right here? Do you know how important it is? We have one moon that is the what? Yeah, just right size. Life would not exist on Earth without the moon we have, period. And we could spend a long time talking about that. And all these other things. And how about the properties of the biochemicals like DNA and proteins? How about cells and genetic code and molecular machines? That's tomorrow and the next night. Hundreds of factors, class, all of which have to be every one of them. Hundreds. And I say to you, ladies and gentlemen of the jury, that ought to be sufficient to convince anybody this system in which we live was not a natural thing. Somebody tampered with this and made it just right. It is unbelievable otherwise. So here's the cell. And look at what you're dealing with here. The cell is down at the level of nanometers. I put this chart up here to give you some idea. A nanometer is, anybody know what 10 to the minus 9 is? That's one what? Billionth. That's the kind of size we're talking about in cells. So here's a meter stick. It's about this long. Take that length and divide it up into 1 billion equal parts. One of those is a nanometer. That's the size we're talking about. In class, what we have learned is that down to that little teensy size, there's design everywhere. Everywhere you look. And it's more magnificent than what you see out there in outer space. So from the largest thing we can observe, the farthest away, to the smallest thing we can possibly observe, everywhere you look, there's design. And in every case, it has to be. Folks, I know you've been there a long time, but don't fade out on me. So here's some things that are those sizes, just to give you an idea. Frog eggs are about 1 millimeter in size. Biological cells are micrometers. But we're talking down here in the size of DNA and antibodies. That's nanometers. And everywhere you look, there's design. So I want to introduce you as my closing point tonight to Dr. James Tour. Dr. Tour is professor of chemistry, materials science, and nanoengineering at Rice University. He is a world-renowned nanoengineer. That means he's doing engineering down at the 1/1000th of a meter level. We're trying to figure out how we as humans at our level can do what the nanometer level's already doing. And we're getting better at it. But we're a long way from doing as much as nature already does by itself, thank you. So I got to talk to you a little bit about Dr. Tour. He's a Messianic Jew. You know what that means? That's a Jewish person who has come to believe Jesus is the Christ. He's a firm believer that Jesus is the Christ. And if you were to go to his website, he would tell you why you should believe in Jesus. He gives you a whole list of reasons, and the biggest one is because Jesus was raised from the dead. And then he gives you all the reasons you should believe he was raised from the dead. Don't you love that? Openly, as a professor at Rice. And I can assure you he's received grief from that from his own compatriots in the science department, up to and including getting his financing removed as a research scientist. I know, because I went to his office and visited him personally with my Marilyn, and he told us the story of how they about destroyed him as a scientist, though he's a world-renowned nanoengineer, because they can't stand it when one of those guys is a believer in God. Well, here's one of the things he's done in connection with medicine. He's learned how to take carbon at graphene level. Graphene, class, is a single layer of carbon, one atom thick. It's impossible to even do that, but we do it. And what he's doing is learning ways to use that material for all kinds of things, like this one. You take a little mouse, like he did, and cut his spinal cord. Sever his cord. That's not healthy. In between where he severed it, he placed graphene and some medications and put it back together and turned that little mouse loose in his cage. And in a period of about a month, that mouse was almost 80% recovered. I mean, would it be good if we could take people whose bones were broken and severed and put them back together again? Somehow that's beginning to happen. And it's partly due to his research. The guy's amazing. He probably has 150 patents on things that he's invented. He's brilliant. So he and his compatriots decided if you're going to do things at the nano level, certainly one thing you should do is build a car. So what you're looking at is the first nano car. That is made out of one molecule. These are the wheels. This is the axles. This is the drive shaft. This thing rotates, which allows it to move. And you see a picture here. And over here is a picture. You can see that it's moved from here to there, to there, to there, to there. You can make that little thing move with light or chemicals. So we've got nano cars that can move around. Made out of one molecule. And of course, people, somebody else was on Earth trying to make the same thing, right? We're always competing. And once you make a car, what do you got to do with it? Well, you got to have a race. So I want to tell you that the first international nano car race was conducted April 28th and 29th, 2017 in Toulouse, France. Those of you that were here yesterday, I mentioned Toulouse in the class yesterday morning, you remember? It's in southern France. But this is a big deal. They had a nano car race, and here were the folks that entered. The Austria-US team was the University of Graz and Rice. This is Dr. Tour's team. And France, Germany, Japan, Switzerland, and another U.S., Ohio University, all entered that race. And I'm happy to tell you, class, that when that race was completed, the Austria-US had won the whole race by going 150 nanometers in 1.5 hours. I mean, that's whipping along, isn't it? A nanometer is 1/1000th of a meter. Yeah, I probably moved that much in an hour and a half. No, folks, that's whipping along for a nano car. And it's remarkable what they accomplished. Switzerland came in second with 133 nanometers in 6.5 hours. And everybody else gave up. You know why, class? Because it's hard to make nano cars, that's why. And that's my point. So here is a paper describing what they went through. Their first generation nano car turned, the rotor here, turned 1.8 revolutions per hour at 60 degrees. Are you with me? That means that thing turned around almost 2 times in an hour. It went nowhere. So, of course, they couldn't run that thing. It would never win anything. So they started over, class, and they built the second generation right here. And I want you to notice something very interesting. The only difference between this first generation and the second generation is that little S right there. That's a sulfur. You see there's 1, 2, 3, 4, 5, 6, and the sulfur's one of them. This is a 5-carbon chain with no sulfur. And with that one tiny change, it changed to rotating 3 million times per second. And that's why they won the race. Now listen to me closely, class. How do you think they got here from this one? I'll tell you how. They started over and used what they learned in the first one to try to work their way through to another. Did they know they were going to end up here? No, they did not. But as good engineers, they used what they learned and they reworked and reworked and reworked and reworked over years until they finally got one that really worked. That's the way these kinds of things happen. Not by natural selection, acting on natural variation over millions of years. Here's what Dr. Tour says about it. The nano cars built by Rice University team were much smaller and far less complex than the kinesin and dynein walkers and other molecular machines common in every living cell. You hear what he's saying, class? What we've done is nothing compared to what nature's already doing. The Rice team has been working on nano cars for over 20 years. Every molecular machine in living cells is much larger, at least 10,000 times, much more complex and much more sophisticated. Folks, we haven't touched top side or bottom of what nature's already done. Somebody tampered with that. Here's a taste of how much work and intelligence it took to produce the nano car. I want everybody awake. Are you all awake? All right, you keep your eyes up here. I'm going to show you, because when they got finished winning that race, everybody else in the race said, "Are you publishing what you've learned?" He said, "Of course I am. I've already published it." And he produced it in a magazine so they could all read it. So I want you to see page 1. All right? Eyes up here. I'll give you just a minute to kind of glance through that. That's page 1. Do you see what it says? Details of one molecule characterization. You're talking about a machine made of one molecule. And he's giving you the details of how they did it. That's page 1. I thought I'd go on a little further. That's page 2. Are you finished? Yeah, give me a minute. We missed a slide, didn't we, Eric? Did I miss one? There was one more after this one, I thought. Can you enliven it for me again? I think we hid one that wasn't supposed to hide. And if we did, it was my fault, I'm sure.
The yellow background?
It was a page of the magazine.
I see it. Yeah, there.
Can you get that up for me? Don't you lose me, class. I just showed you page 1 and 2, right? Now look, this is where he published it. Whoops. You're doing it right. That's the one I want. Blow it up. Ah, good. Tetrahedron magazine published his article, and look at the date down here. 17th of May, 2017 was when it was received in revised form. The race was in April. Remember that? Look over here. 281 pages. You saw page 1 and 2, right? Does it take a lot of work to produce a nano car? And a lot of intelligence? And he would tell you, we ain't done nothing compared to what we've already observed in nature. And class, don't you forget this if you don't remember another thing. That kind of complexity never comes about without intelligent design. And everybody knows it. And these knuckleheads proceed to tell you it sure looks like a design, but it is not designed. You understand why I get a little tiny bit upset about this? And have someone call me a psychotic, deluded person? It's infuriating. Because the evidence is in exact opposition. We know nano cars were designed by intelligent human engineers. Would you say amen to that, class? Amen. Living cells with all of their thousands of nanomachines, which are far more intricate, complex, interdependent, and full of digital information, were surely designed by an amazing, intelligent designer, whom we call God. Can Christianity and science coincide? The Bible teaches that things which were made cause us to see God. And science shows us that everywhere we look, from the macroscopic to the microscopic, things look like they're made. We see evidence everywhere of a grand designer. That's Michael Behe in his wonderful book, Darwin's Black Box. If you haven't read that one, that's number 2 on the list. Because is it reasonable to believe in God in this scientific age? Christianity and science agree on that. It's never been more reasonable in the history of mankind. And don't you miss tomorrow night and the next night, because we haven't touched the hem of the garment. And my goal, class, is when you walk out of here Wednesday evening after you've been here 3 nights on this, you are stupefied. Because you cannot believe the majestic God you serve. That's my goal. I hope we accomplished a tiny piece of it tonight. Thank you for being here.